Okay, so what I've decided to do, I was going to send you a worksheet answer and also give you assignment for next week. I mean, for this week, it covered the other PowerPoint I just put out. Um, but I've decided I'm just going to make a PowerPoint that gives you guys the answers to uh, worksheet you just did, and also what what you have to know for the next test. I'll just put it all here on this PowerPoint. So so what I'm gonna do is I'm gonna go through the I think 19 or 20 uh, covalent molecules that I gave you. Come up with their structures. Do it step by step. And then also what we want, part of the assignment I was gonna give you guys is that what you need to do is you have to figure out if the molecule is polar or nonpolar and what is the shape. And so I'll go through that. I'm going to actually do all that now. So I'll go through all of them and figure out their structure. And then we'll determine if they're polar or nonpolar. Now the other thing you have to know for the test is the three different types, the two main types of interactions, dipole. You have to be able to define them, and also London dispersion forces, and also what happens when you combine the two, like oil and water. Also know about hydrophilic and hydrophobic. Uh, if you're going to take Chem 111, this section we're covering here, this test right here, is what we're basically going to start with when we get into Chem 11. If you take it from me, so it'll be right on your fingertips if you take it soon. All right, so I gave you a series of covalent molecules, and they're here, and these guys already, methane, water, ammonia, carbon dioxide, HCN, HF. I already did that on the previous PowerPoints. Okay, so but I will show you at the bottom, review them and apply them. So the rest of them the other 12 or so, is that'll go over how you figure out their bonding. And so one of the things that you have to keep in mind is this. So the periodic table, so what we'll end up going through is when you figure out the structure when you figure out the structure bonding of a molecule, what you do is you come up with a skeletal structure. Okay, so you have a center atom and outside atoms. Okay, the outside atoms are the ones that you're going to give the bonds and lone pairs to. So like for instance, if you had water, H2O, so HOH. Okay, so O is in the middle and H is on the ends. Okay, so what you do is you give the hydrogens the number of lone pairs and bonds that it has. So the number of lone pairs and bonds they have. So here you have the outside atom. Hydrogen has one bond, no lone pairs. So you would give each hydrogen one bond. Okay. And then we'll show examples of that in the other ones. So let's say you have another molecule that has Cl, O, and Cl. So oxygen is again in the middle, and the Cl's on the outside. So what you're going to do is you're going to figure out how many bonds and lone pairs chlorine has. Well, it's in the same column of fluorine, so it's going to get the same bonds and lone pairs. So fluorine gets one bond and 3 lone pairs. So chlorine will get the same. So whatever elements are in this same column will get the same bonding as the element that's in the second row. Okay, that's that's for outside atoms only. The center atom sort of just falls into place. Okay, down here is the valence electrons, 1, 2, 3, 4, 5, 6, 7. You notice I've cut a lot out of the periodic table to only use the elements that we really are concentrated on here. And actually, we won't be using these guys at all lithium, beryllium, boron, aluminum, magnesium, sodium, because they're metals and they don't really apply to covalent compounds. Okay, but one thing to notice about the valence electrons and the column numbers is 1, 1, column 2, 2 valence electrons, column 13, 3. Now I noticed on the test, some of you were putting down that carbon had 14 electrons. Okay, it only has 4. Right, it only has 4 valence electrons. And then nitrogen has 5. It's in column 15. Oxygen has 6, and fluorine has 7. I left off the noble gases because they don't hardly participate in covalent bonding. Now the other thing you'll notice is there just says 1A, 2A, 3A, 4A, 5A, 6A, 7A. Some periodic tables have these and some don't. So you can actually tell how many valence electrons if you look at the A's. So if you have these columns available, so if it's a 2A, you know how many valence electrons. So I'm going to relate back to this relationship here. Okay, so everything that's in this column here, nitrogen and phosphorus, if it's an outside atom, it'll get 3 bonds and 1 lone pair. Okay, if it's in carbon's column and it's outside atom, it'll have 4 bonds and no lone pairs, and so forth. Okay. All right. So let's get working through it. So keep this in mind. Also, remember, in terms of electronegativity, we found is that atoms to the right and up have higher electronegativity. Usually, the atoms on the outside will have higher electronegativities, and the middle atom, the center atoms, have lower electronegativities. Okay, so you'll hear me say that and a couple of these here. Okay, so remember, you can look back at this as we go through this. Okay, so we start out with HBr. What you do is you count the number of valence electrons. Hydrogen has 1, bromine has 7. You add them together, they have 8. Okay, so bromine is in the 17th column, so it has 7 valence electrons. Draw a skeletal structure. Okay, so which atom are you going to give the bonds and lone pairs to? Okay, so you got to pick one of them, and it actually doesn't matter which one you pick, but we're going to pick hydrogen because it has a higher electronegativity because it's higher up. Okay, so hydrogen has 1 bond, so put that there. Okay, so after you do that, you count the number of dots. Every dash is equal to 2 dots. So we have only 2 dots here. We need 8. So where are the other 6? The other 6 are on bromine, and you just put them on as pairs. Okay, and if you notice, you're done. Okay, adds up to 8. Now the other thing you'll notice, if you go back to the previous slide and look at bromine, bromine is in the 17th column. And everything in the 17th column, usually if it's an outside atom, and in fact bromine is an outside atom here, would have 1 bond and 3 lone pairs. So you could have started with bromine and the hydrogen, it would have worked out as well. If you would have started with bromine, you would put 1 bond, 3 lone pairs on it. Okay, counted them up and you would have been done. Okay, so now the shape of this molecule, so we have linear, trigonal, planar, tetrahedral, trigonal, pyramidal, and bent, and you go back and look at it. Okay, you won't see any of them look like this. This does not have a center atom, so this does not have a shape that's associated with it. This is a polar molecule because it has different things attached. Okay, remember, you can tell if a polar molecule is polar or not by if it has same things or different. Now on a test, there'll be a question that says, what is polarity? Okay, don't say it's, how do you know, don't say, if I ask you what a polar molecule is, don't say it has different things attached to it. Okay, this is a way of how to identify polar molecules. The definition of a polar molecule is that it has an unequal distribution of electrons, shared electrons on the molecule. Okay, all right, so keep that in mind as we go through this. Okay, the next one is O2. So first thing to do is count the number of valence electrons. Each oxygen has 6. It's in a 16 column, so there's a total of 12. Draw the skeletal structure. Okay, so what you're going to do is both have the same electronegativity, and there's no real center atom, so you can pick either one. So oxygen gets 2 bonds, 2 lone pairs. So I'm going to give the left oxygen 2 bonds and 2 lone pairs, and then I'm going to count them up. So now it has 4 dots, 1, 2, 3, 4, and 2 dashes. The 2 dashes are 4 dots as well. So 4 plus 4 is 8. Okay. Well, we need 12. Okay. So we need 4 more. Well, where do the 4 go? They go on the other atom over here. Okay. As this right here. And if you look, so if you notice, both high oxygens have 2 bonds and 2 lone pairs. Okay, what's the shape of this? Does not have a shape, and this is a nonpolar molecule because it has the same thing. You can identify that because it has the same things attached. Okay, N2. Okay, just like previous one, it looks like O2. If it's N2, it's going to be a little bit different. Nitrogen has 5 valence electrons. It's in a 15 column, and there's 2 of them. So 5 plus 5 is 10. Here's the skeletal structure. Okay, what you can do is you can give either one of the nitrogens its lone pairs and bonds. Nitrogen has 3 bonds and 1 lone pair, so you put 1, 2, 3. Don't have any bonds hang off. Don't have a line over here and a line over here. The lines got to connect. So nitrogen can have 3 different ways of bond. It could have 3 single bonds, 1 single and 1 double bond, or just 1 triple bond. And this one's the one that makes sense here. So it has 1 bond, 3 bonds and 1 lone pair. You count them up. So there's 2 dots and 3 dashes. Each dash is 2, so it's 6 plus 2 is 8. Well, we're missing 2, so we just put them on the nitrogen that doesn't have we didn't start with. Okay, and you count them up now, and now you got 10. 2, 4, 6, 8, 10. Okay, now again, this molecule doesn't have a shape, and it's nonpolar because it has the same things attached to each other, or to the central bond. Okay, F2, same kind of idea. You have 2 fluorines. Each one has 7 valence electrons. So 7 plus 7 is 14. Skeletal structure is FF. Again, it doesn't matter which fluorine you start out with. So fluorine gets 1 bond and 3 lone pairs. So I put it here. I count up the number of dashes and dots. Okay, there's 6 dots and 1 dash, so that's 8. Okay, I need 14, so I need to put 6 more. Okay, I'm not putting them on where I started, so I put them over here as pair, pair, pair. And you look, each fluorine now has 1 bond and 3 lone pairs. And again, this is no shape, and it's nonpolar. Same things attached. Okay, silicon tetrahedride. Okay, count the number of valence electrons. Silicon has 4. Each of the hydrogens have 1 electron, so it's going to be 4 from silicon and 1 from each of the hydrogens, so it's 8 altogether. Okay, the skeletal structure is like this. Silicon goes in the middle. Outside atom, you give it number of bonds and lone pairs. That's suggested, and that's hydrogen. It gets 1 bond. You put those on. Then you count number of dashes, the dots, I mean. So dots are going to be, every dash is 2 dots. So you got 2, 4, 6, 8. 8 dots, 8 valence electrons. Check it off, you're done. Okay, what's the shape? Tetrahedral. It has, the center atom has 4 things attached. This is nonpolar molecule because it has the same things attached to the center atom. Okay, CF4 turns out to be very similar. Carbon has 4 valence electron. Each fluorine has 7. It's going to be 4 plus 4 times 7. So 4 plus 28 equals 32. Here's a skeletal structure. Put carbon in the middle and surround it with fluorine. Okay, the outside atom gets its number of bonds and lone pairs. So if you notice, we don't even care what's happening to the center atom because it always seems to be working out. Okay, so fluorine gets 1 bond and 3 lone pair each one. Okay, so right now count everything up. Well, there's 4 dashes. That's each one, so that's 2, 4, 6, 8, and then there are 6 around each of the fluorine. So it's 6, 12, 18. 26 plus, so we have 8, there's 32 altogether, which is the same as the number of valence electrons, and check it off, you're done. What's the shape? Tetrahedral. It's 4 things attached to the center, and it's nonpolar because it has the same things attached to the center atom. All right, H2S. Count the number of valence electrons. Each hydrogen has 1, and the sulfur has 6, so it's going to be 1 plus 6 plus 1, or 8. Here's the skeletal structure. Hydrogen's on the outside, so give it its number of bonds and lone pairs, which is 1. Okay, so here's our first part. Okay, now count the dots. Each dash is 2, 2, 4, which is short of 8. Okay, so we need 4 more. And the 4 go on the center atom as 2 pairs. And guess what? You're done. Ding. Okay, now notice, it turns out that sulfur is in the same column as oxygen, and that column gets 2 bonds and 2 lone pairs. And look, it works out. Okay. What's the shape? So this molecule has 2 connections and 2 lone pairs. So this would be bent. Now, if it did not have lone pairs, it'd be linear. Okay, the polarity is polar. It has different things attached to the center atom. Now, be careful here. It looks like it has the same things. It looks like it has 2 just hydrogens, but also have lone pairs. So lone pairs count as a thing. So the center atom has lone pairs and hydrogens. So this is a polar molecule. Okay, COCl2. Count the valence electrons. Each carbon has 4. The carbon has 4. The oxygen has 6. And the chlorine has 7. And there's 2 of them. So it's going to be 4 plus 6. So it's 10 plus 2 times 7 is 14. So there's 24 valence electrons. Build a skeletal. Okay, so there's 2 lone atoms here, carbons and oxygen. All right. Carbon has a lower electronegativity. You can kind of look at the periodic table. Oxygen's further up and the right, so it's more. So you're going to put carbon in the middle. Usually, carbon will usually go in the middle of a molecule. Okay, so here's our skeletal structure. So what you do now is you give chlorine its number of bonds, lone pairs. So it's the same column as fluorine, so it gets 1 bond and 3 lone pairs. Oxygen gets 2 bonds and 2 lone pairs. And the other chlorine, the same thing. All right, now count everything up. So there's 4 dashes, which is equal to 8 dots, plus the other 16 dots. 2, 4, 6, 8, 10, 12, 14, 16. 24 dots is equal to 24 valence electrons. You're done. Okay, what's the shape? Center atom has 3 things attached. Okay, don't count the number of bonds. It has 2 chlorines and oxygen, so it's trigonal planar. Okay, no connections and 3 connections, no lone pair center, and it's a polar molecule because it has different things attached. In this case, it has 2 different types of atoms. Okay, PBr3, count the valence electrons. Phosphorus has 5, each bromine has 7, so it'd be 3 times 7, 21, plus 5 is 26. Skeletal structure, put the phosphorus in the middle. Okay, it doesn't matter how you put the Br. I put the Br on top. You could have put it down here on the bottom. All right, so Br is on the outside, so you give it its number of bonds and lone pairs, which is the same as fluorine. So it gets 1 bond, 3 lone pairs, each one of them. Okay, now you count the dots. So each dash is 2. So, so it's 2, 4, 6. And there are 18 dots. 2, 4, 6, 8, 10, 12, 14, 16, 18. Plus the 6 that are in the dashes is 24. And we're 2 short of what we expect. Well, where are we going to get those 2? Where would we put those 2? We put them on the phosphorus. Okay, and again, if you look at the periodic, if you look at the original table, this is in the same column as nitrogen, and nitrogen gets 3 bonds and lone pairs, and you notice this guy ends up getting 3 bonds and 1 lone pair. So, like I said, you don't even have to worry about the center atom using this method. It just works out. What is the shape? Well, there's 3 things connected to the phosphorus, 3 atoms. So it's going to be trigonal, just like the previous one. But this one's going to be pyramidal. That's because of this lone pair. Okay, if the lone pair is not there, it's planar. With the pyramidal, it's with the lone pair, it's pyramidal. It's a polar molecule. Okay, why is that? Because it has two different things attached. It has bromines and lone pairs. Okay, HNO. Count up the valence electrons. Hydrogen's 1, nitrogen's 5, and oxygen is 6. So that's 12. Here's the skeletal structure. Okay, hydrogens always go on the outside. Don't put them in the middle. Oxygen has a higher electronegativity than nitrogen. It's further to the right, so put nitrogen in the middle. Usually, oxygen will go on the outside unless there has hydrogen attached to it. Okay, so what we're going to do now is we're going to give hydrogen its 1 bond, and we're going to give oxygen its 2 bonds and lone pairs. Okay, like in the diagram. Now we count up the dots. Okay, so each dash is 2, so 2, 4, 6, 8, 10. So there's 8 dots on this structure. We're 2 short. We need 12. We only have 10. Where do we put the 2? We put the 2 right here. And you got your structure. Okay, what's the shape? Okay, the center atom has 2 things attached, so it could be linear or bent. The center atom has lone pairs on it, so it's going to be bent. It's a polar molecule because nitrogen has more than 1 thing attached to it. In fact, it has 3 different things attached to it. It has a hydrogen, a lone pair, and an oxygen. Okay, SCl2. Okay, sulfur has 6 valence electrons. Each chlorine has 7, so it's going to be 6 plus 7 plus 7, which is 20. Skeletal structure, sulfur in the middle. Chlorine outside gets 1 bond with 3 lone pairs. Count them up. You got each dash is 2, 2, 4. Then the pairs are going to be, so it's 2, 4, 6, 8, 10, 12, 14, 16. We need 20. We need 4 more. Where the 4 are going to go? In the center. As 2 pairs. And you're done. Okay, what's the shape? Well, the center atom has 2 things attached. Two connections, so it's going to be either linear or bent. It has lone pairs on the center atom, so it's going to be bent. Okay, if it didn't have lone pairs, then it would be linear. It's polar because the center atom has more than 1 thing. It has chlorines and lone pairs attached. Okay, H2. Pretty simple. So each hydrogen has 1 valence electron. So 2 times 1 is 2. There's skeletal structure. Again, you just give one of the hydrogens. So I'm going to pick this hydrogen here and give its one bond. Okay, count up number of dots. Each dash is 2. You're done. Okay, so you don't have to add anything more. Again, we don't have a shape associated, and this is nonpolar because it's just the same things attached to the bond. Okay, Cl2. This just looks quite a bit like F2 that we did earlier. They're both in the 17th column. So chlorine has 7 valence electrons, so 7 plus 7 is 14. Here's the skeletal structure. Pick one of the chlorines to give its bonds and lone pairs. So chlorine has 1 bond, 3 lone pairs. Count them up. 2, 4, 6, 8. We need 6 more. So the other 6 go on the other chlorine. Count them all up, you're done. And you start over this chlorine, you would have got the same answer. There's no shape, and it's nonpolar because it has the same things attached to the bond. Okay, finally, of these guys, so we have silicon disulfide. You count up the number of valence electrons. So it's going to be silicon has 4, and each sulfur has 6, so it's going to be 4 plus 6 is 16. Here's the skeletal structure. Okay, the outside atom gets the number of bonds and lone pairs. It's in the same column as oxygen, so sulfur gets 2 bonds and 2 lone pairs, each one. All right. Now count up all your dots and dots. Each dash is worth 2, so 2, 4, 6, 8, 10, 12, 14, 16. This is not a dot. This is part of the eye. So there's 16 dots. Okay, and we needed 16, and it's done. Okay, what's the shape? Okay, it has 2 things attached to the center atom, so it's either linear or bent. It has no lone pairs on the center atom, so it's going to be linear. Okay, this molecule is nonpolar because it has the same things attached. Now I made a mistake here. Okay, this should say nonpolar because it has the same things attached to it. Okay. All right, and what I'm going to do is go over the ones that we did already in the previous PowerPoint in terms of their shapes and polarity. So water, this is a structure we came up with. Okay, it has two connections and 2 lone pairs, so it's going to be bent. Just on the center atom. The center atom has different things attached to it as lone pairs and hydrogens, so it's going to be polar. NH3, we came up with this as its structure. Okay, and so it has the nitrogen has 3 atoms attached, so it's going to be a trigonal, and it's either planar or pyramidal. The lone pair on the center atom makes it pyramidal. It's a polar molecule, and you can tell because it has more than one thing attached to the center atom. It has hydrogens and lone pairs. Okay, this should be CH4, not NH4. So CH4, methane, we came up with this as its bonding structure. It has 4 things attached to the center atom, tetrahedral. Okay, the center atom has the same things attached, so it's a nonpolar molecule. All right, carbon dioxide. Carbon dioxide, we came up with this as its structure. Okay, and so again, what you would do is you'd come up with the skeletal structure, put the O and C, O, C, and O. Okay, oxygen's on the outside, so you give its number of bonds and lone pairs. So there's each oxygen gets 2 bonds, 2 lone pairs. And then first of all, you count the number of valence electrons, and which would have been 4 plus 6, which is 16. So so the number of dots are going to be 2, 4, 6, 8, 10, 12, 14, 16. So this is the structure. Okay, so we go back through each one of these. That's how you do it when you come up with the structure. But let's go back to the polarity. This is a linear molecule. The two atoms connect to the center atom. No lone pairs, so it's not bent. It has the same atoms attached. So this is a nonpolar. Same things attached, so it's nonpolar. Going back over bonding again, okay. For water, the skeletal structure, the number of valence electrons, so it's 1 plus 1 plus 6, 8. Okay, the skeletal structure is HOH. Okay, give hydrogen its number of bonds, 1. 1. So you would have each dash of 2, 2 and 4. That means you need 4 more in the middle. So you put 2 pairs. Okay. The ammonia, I'm just going over how we come up with these bonding structures. NH3, how many valence electrons it has? 5 plus 1 plus 1 plus 1 is 8. The skeletal structure was like this without the bonds and lone pairs. You give the outside atom its amount of bonds and lone pairs. So hydrogen gets 1, 1, 1. Then you count up the number of dots, 2, 4, 6. You need 2 more, so you put 2 more on the nitrogen. Okay, CH4, that should be a C. So carbon has 4 valence electrons. Each hydrogen has 1, so it's 4 plus 1, 1 plus 1 plus 1 is 8. So skeletal structure is this structure here without the bonds. Okay, then you give hydrogen its number of bonds. Each hydrogen gets 1 bond. You count them up. And then 2, 4, 6, 8. You're done. Okay. Okay, you go back and look at the previous slideshow to see how I got those. I'm just kind of doing a review of them right now. Okay. Next set. Okay, so I have CH2O. Let's go over the bonding first. So this looks quite a bit like one we just did, CCl2O. Okay, so number of valence electrons is 4. Each hydrogen is 1, so it's 4 plus 1 plus 1 plus 6 is 12. Okay, skeletal structure would look like this without bonds and lone pairs. Give the outside atoms its number of bonds and lone pairs. So it's going to be each hydrogen 1 and oxygen gets 2 and 2. Okay, then count everything up 2, 4, 6, 8, 10, 12, and you're done. Okay, in terms of its shape, it's trigonoplanar. Center atom has 3 things attached. No lone pairs, so it's trigonoplanar. It's polar because it has different atoms attached. It has hydrogen and oxygen. Okay, HCN. Okay, so we'll go over the bonding. A quick review of the bonding. So each hydrogen has 1 bond, 1 valence electron, 4 and 5. So it's 1 plus 4 plus 5 is 10. Right. The skeletal structure would be this structure without bonds, lone pairs. Give hydrogen and nitrogen its bonds, lone pairs. Hydrogen has 1. Nitrogen gets 3 and 1. Put those in. Count everything up. Okay, 2, 4, 6, 8, 10. And that's what how many valence electrons, so you're done. Okay. HF. We did HF. No, okay, go back to HCl. Is it linear? What's its shape? It's linear because it has 2 things attached. Okay, with no lone pairs. It's polar because it has the center atom has different things attached. It has hydrogen and nitrogen. Okay, HF. It was just like HBr in the last previous and up above. And it doesn't have a shape. Okay, it's not applicable. It's polar because it has different things attached. Okay, and lastly, you didn't have to do this one, but I just want to show you is that there was tetrahedrals, the ones that we showed you. We have molecules that were tetrahedral. In each of those cases, the molecule ended up being nonpolar. Well, you can have tetrahedrals that are polar as well. And here's an example. You didn't have to do this one, but notice it's that the carbon has 4 bonds. So it's tetrahedral, has different things attached to it. So it's polar. Okay. All right. So again, the this on the next test, I'll give you chemical formulas, and you're gonna have to come up with the bonding structure, and you're gonna have to tell me it's polar or nonpolar, and you're gonna have to tell me if their shape. You're gonna have to define what polarity is. You're gonna have to tell me why a molecule is polar or nonpolar, and it's not because of it has different same things attached to it. Okay, it's how the electrons are distributed. You're going to have to define what polarity, what dipole interactions are. Okay, so dipole interactions and London dispersion forces are molecular interactions. That means interactions between molecules. So you're going to have to define both of those. Okay, so right, just a little. I don't know if this will be on the test or not, but I just want to go over it. Okay, when you melting. So let's say I have some ice. Ice is water, obviously. Okay, and what makes ice ice? It's a solid. That means the water molecules are interacting with each other really, really, really well. Okay, there's a lot of interactions. Now, what melting does is it breaks the interactions between the molecules. It does not break bonds. Okay. So when you melt something, you're breaking the connections, the molecular interactions between molecules. When you boil water, it's the same thing. You're turning the water from liquid into gas. So in water, the water molecules are all interacting. When you heat them up, they get enough energy to break apart from each other and become the gas state. Okay. The bonds in the water don't break. It's still H2O. It just changes its state. Okay. I'm not sure if that'll be on a test or not, but I want you to know that. Make sure you know that. A lot of people do not know what melting and boiling is entailed. They'll say that the water breaks its bonds. Okay. If you take 111, we'll talk about melting of fat. Okay. If you melt the fat, what you're doing is you're changing, like butter. Let's say you're melting butter. When you melt butter, what you're doing is, when butter is solid, it's butter molecules all interacting with each other. And when you melt it, what you're doing is you're breaking apart the butter molecules from each other. Right. So, okay. So that's all. So that's it. So I would let you know when the test is. It's going to be early next week, but it's going to cover exactly what I'm just telling you right here. Okay. All right. Good luck.